All right, so let's talk about chapter 3, relations and functions and graphing. So first thing we need to recall is how do we graph? How do we plot points? Okay, so this is pretty simple, pretty straightforward. All right, and the one thing you need to remember is our points are alphabetical, meaning our X value comes first, followed by our Y value. So I'm not going to label all the points, but I'm going to label some of them. So these are all X, Y, X, Y, X, Y, X, Y. And these over here are our axes. The horizontal one corresponds to the x-axis. And the y, the vertical one, is the y-axis. And these points, just kind of think of like battleship, okay? They just correspond to a location on this coordinate plane. So for example, A is at 4, 8, so I'm going to count over to the right 4 blocks because the right is a positive direction and left and down are negative directions. So 1, 2, 3, 4, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is A, 4, 8. B is negative 3, 1, so that's going to be to the left 3 units, 1, 2, 3, and down 1 unit, right there. That's B, negative 3, negative 1. C is 9, negative 5, so 9 is going to be to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 5, 1, 2, 3, 4, 5. So that is C, 9, negative 5. D would be negative 6 sevenths to the left 6 units, 1, 2, 3, 4, 5, 6, and up 7, 1, 2, 3, 4, 5, 6, 7. So that would be D, negative 6, 7. E, the last one, I'm going to let you do the last 5, it's negative 5, 5. So we're going to go to the left 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5. So that is E, negative 5, negative 5. Now, these quadrants, before I let you get there, they have names. This is the first quadrant, the second, this is the third, and this is the fourth. All right? My axes they started out with are the X is horizontal, the Y is vertical, and this point in the center, that is the origin, and it is the point 0, 0. So why don't you guys try doing the next 5? I'll give you a couple seconds to do them. All right, it's enough time, I guess, because I'm kind of bored here. So 3, negative 1, so we're going to go to the right 3, 1, 2, 3, and down 1. That is F. G is negative 4, 4, so that's going to be to the left 4, 1, 2, 3, 4, and up 4, 1, 2, 3, 4. That's G. H is 2, 10, so 2 to the right 2, up to 10. That is H. I is negative 3, 5, so to the left 5, or left 3, 1, 2, 3, down and up 5. 1, 2, 3, 4, 5. So it's right there. I. And J is 7, 0. So that's to the right 7, 1, 2, 3, 4, 5, 6, 7, and I don't go up. So that's J. So it's a quick recap of how to graph, all right, and how to plot those points. So now, here we have a graph with a bunch of points on it, and we are asked to identify the coordinates of them. So we're just going to kind of do the reverse of what we did. We're just going to count it out. Okay, so to get to A, we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So since I went to the left, it's negative 10, 12. B, okay, once you get better at this, you'll be able to go through this quickly. So 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 8 and 12. C, that's the left one, and up 1, 2, 3, 4, 5, 6, 7, 8. So that's -1, 8. D, I didn't go anywhere, so that's 0. And we went up 1, 2, 3, 4, 4. Now notice they have these darker lines on there. That is telling me that each of those lines are 5, which might make my answer, or to get to my answer a little bit quicker. So we know here, E is at 7 and up 4. So 7, 4. I don't necessarily have to count it out. Okay, but if you need to count it out, feel free. Okay, let's keep going through these. F is -4, 0. G would be at 1, 2, 3, 4, 0. H would be at 0, -4. I, well, we got to find I. I's all the way down here, so that looks like it's going to be at, let's see, 5, 10, 11, 12. Okay, so -12 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be -12 and -10. And J is all the way down here. And that's going to be at 10 and negative, let's see, 1, 2, 3, -13. Which points are in quadrant 3? So if you recall from earlier, okay, quadrant 3 is this quadrant down here. And the only point in that quadrant is I. F and H are on the axes, so that's not going to be in any quadrant. Which points are not located in the quadrant? Well, that's going to be point D, that's on an axis. F, G, and H, they are all on an axis. Okay? Which groups of 4 points create a rectangle? Okay, so we're just trying to find a rectangle there. So if we look at these, I think the easiest rectangle for me to locate is going to be D, F, H, and G. Order doesn't really matter here. And which groups of 3 points create a line? All right, that means I need 3 points in a straight line. And if you look, looks like those 3 are in a straight line. So I can figure it out. So I can count my slope. 1, 2, 3, 4. 1, 2, 3, 4. 4 over 4 is 1. So 1, 2, 3, 4. 1, 2, 3. Ooh, see, I was wrong on that. So I've got to find 3 points in a line. So let's go ahead and look again. Keep going through here, just looking for ones in a line. And I think 3 points create. Wow, it's a toughie. What about F, D, and B? So let's count that out. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 4 over 4 is 1. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So there you have it. So it's F, D, and B. Because to get from F to D, I went up 4 to the right 4, and 4 over 4 is 1. And here I went up 8 and to the right 8, and 8 over 8 is 1. So that's how I know they're on the same line. All right, so now we can get started with 3.1, which is an introduction to functions. So basically, a grouping of points is like a relation. When I say this corresponds to that, that's a relation. But a function is a specific way the points are paired. So a relation puts inputs with outputs. And relations can be expressed in 3 ways. We have a table here, which is to our left, that has an input side and an output side. Then we have a graph, which we were just talking about. And then we have a mapping, which is kind of like you have a group of numbers and then arrows coming out and going to other numbers. Okay, so those are our three relations that we can have and the way they look. Now a function. Okay, now functions are very important in this world. Okay, and we're going to talk about them. So a function is a special type of relation in which I put something in and I get exactly one thing out. Okay, now why is that very important? Well, let's talk about a vending machine, for example. A vending machine is a prime example of a function. If the vending machine wasn't a function, okay, well, my life would be very interesting. So we have a vending machine here at Pencrest High School. It's down by the gym, okay, and it's got carrot sticks in it. It's got pirate booty. It's got some Gatorades, some protein milk. Well, let's just talk about that for a second. And if it was just a relation, here's how it would work. It would go down there and Mr. Harmon really loves that pirate booty snack. So he pretty much takes his money, it's like $1, puts it in, hits C8, hoping to get that pirate booty, and he gets out carrot sticks. That's a relation because it means like I could get whatever's in there. It's not a one-to-one correspondence, okay? So I was hoping to get pirate booty. I typed in the numbers, but yet I got carrot sticks, and I wouldn't be happy. That's a relation. But a function works like this. You put something in. I put in, all right, for example, I put in that A1 in this one. And it looks like I'm going to get those Lay's potato chips, okay? I only get one thing out. That's how a vending machine works, and that's a prime example of a function. You put one thing in, and you get one thing out. All right, so let's go through some of these notes. Sorry, it's a little scattered. All right, it's a little PowerPoint that we used to use, so we're going to keep using it because it works out well. So we have very distinct things here that I need to go over before we start. So a relation is a pairing of inputs and outputs, variables X and variables Y, okay? And an ordered pair is just consisting of an X value and a Y value, an input and an output, okay? And then X values, these are important, so please put a star next to them. Now, why am I telling you to put a star next to them? Because, long story short, I'm going to interchange these names. So we have X values, inputs, domain, and independent variable. All of those names are talking about the same thing. And Y values are talking about outputs, range, and dependent variables. So they're all the same thing. So let's go down here and let's talk about inputs and outputs. All right. So in the first one, it says, what is the domain and what is the range? So the domain, I don't know if you can see all these little arrows here. Okay. The domain is talking about all of my X values. So my domain is 0, 1, 2, 3, 4, and 5. And my range is talking about all of these Y values. So when I'm asking you, what is the domain? I'm just asking, what are my X values? When I ask you, what is the range? I'm just asking you, what is my Y values? So -4, -3, -2, -1, and 0. Now I can also express that in a different manner. Like here, this is a mapping. Here, what is my domain? So my domain in this case is going to be 4, -5, 0, 9, and -1. And my range, notice, is just -2 and 7, because those are my outputs. Now, since we are talking about domain and range, we have to talk about what makes something a relation and a function, or what's the difference between the two. So a function is this. It is a relation in which every input is paired with exactly one output. Meaning your X values can't repeat. I can't have, say, an X value or an input as like 2, okay, and then see another 2 and have those numbers go to 2 different things. And I'll show you what that looks like. So basically this, I want you to look at your domain, all right, your x values, and I want you to see if any of them are repeated. If they are, well, then that's going to tell you something. It's going to tell you to watch out that it might not be a function, okay? So is a relation a function? Well, it can be, not all the time, okay? So long story short, if the set of ordered pairs have different x coordinates, it's a function, okay? If the set of ordered pairs has at least one pairing that is repeated, it's not a function. And the y coordinates, they don't matter. Nobody really cares about them. So let's talk about examples 3 and 4. Is this a function? So all I'm going to do is, in order to determine that, I'm going to look at my x values. Notice 0, 1, 2, 3, 4, 5. Do you see how they're all different? So this is a function. And here with example 4, all right, let's look at this. All right, so for example 4, we're going to look at that. And again, I'm just going to look at my domains. Now, I have -1, 1, 2, 0, 0, and -2. Well, I want you to pay attention to this and this. Notice I said 0 twice. And it goes to 2 different values, so it's not a function. Not a function. Now, in terms of a mapping, well, I think this is easier to see. So I'm going to look at my mapping. So it says which mapping represents a function. And I'm going to look at my inputs, which are these numbers and these numbers. Okay? Now, these numbers on the left, I'm going to pay attention to the arrows coming out of them. Notice there's only one arrow coming out of 3, one arrow coming out of 1, one arrow coming out of 0. But over here on the right, I have one arrow coming out of 2, 2 arrows coming out of -1, and 1 arrow going out of 3. This right here makes choice number 2 not a function. So choice 1 is the function. Again, look at your domain. Notice here in A has multiple arrows coming out of my input. That's not a function. But over here, because each input is going only to one output, notice A goes to 2. That's fine. B goes to 2. That's still fine because they're going, I'm not repeating my input. And C goes to 2. We're still Gucci. So B is my function. So which situation represents a function? Now, these are kind of like word problems. So it says, the items in a store to their prices on a certain date, okay? Or types of fruits to their colors. And they're saying, well, A is, okay? So there's only one price for each different item on a certain date. Meaning, if you go in, you're trying to buy a cup of coffee, it's going to be one exact price. It's not going to be 2. It's like, yo, maybe it's $1, maybe it's $2. I don't know. Got to see. But now fruit, think of, let's think of a red delicious. It's red. It's an apple. But you want to know what else is red? A tomato. That is also a fruit. So because we have, one color, aka red, going to 2 different fruits, it's not a function. So it says a fruit such as an apple from the domain would be associated with more than one color. Okay, in their case, they're using an apple. And they said an apple can go to red or it can go to green. Now, this thing over here is a vertical line test. Okay, and a relation is a function if it passes the vertical line test. So, long story short, I just wanted you to take your pencil and I want you to hold it vertically. Okay? Just hold it vertically on your graph. And you're just going to drag it across the graph. Okay? So, let's see what that looks like. So let's see if I can draw a vertical line. So I'm just going to draw a vertical line, and this is going to be my vertical line. Ooh, not good. Need to do that one again. There we go. Oh, one more time. Nope, don't like it. Hate it. Oh, no, what did I do? All right, here we go. All right, not bad. So what I'm going to take is I'm going to take this vertical line and I'm going to drag it across my graph. Notice my line and my points only touch my vertical line at one point. This would be a graph or a function. This would be a function. But let's go look at this circle over here. Notice when I take my vertical line, I'm dragging across. Whoa, danger, Will Robinson, danger, danger. Notice my vertical line touches right there, not a function. No bueno. So, I'm going to keep that vertical line with me. See it in case I need it. All right. And actually, I am going to take a break and allow you guys to work on some homework.